Good morning, children. Today we are here to discuss Unit 8 Floating Bodies of 9th class. Within this particular class, now we are going to discuss about a new topic. The topic name is Measuring the Force of Buoyancy. What is called as a buoyancy? Buoyancy can be called as nothing but what? Force applied on object in upward direction. In upward direction, if a force is acting upon a body, we will call that one as nothing but what? Buoyancy. To explain that, to define the force of buoyancy, I have taken a beaker in which water is placed and I have taken an object. This object is completely or partially immersed in liquid. As it is immersed in liquid, this particular object experiences one force. What is that force? Upward force it will begin experiences. The experiencing of upward force by an object is called as nothing but what? Force of buoyancy. We'll call that one as nothing but what? Force of buoyancy. This force of buoyancy can be caused by difference in pressure acting in opposite direction. Here you have to observe that itself upward force is acting in this direction and other force is acting in from up to down direction. That is what? Gravity force is acting in downward direction, upward force is acting upon in upward direction. Due to that reason, variation in pressure in opposite direction it will exert. Due to that reason, force of buoyancy will be acting upon an object when it is immersed in water or any other liquid. We can give it up. Units, as it is force, therefore it is measured with what? Newton in SI system. In SI system it can be measured for Newton, therefore unit of that particular one is nothing but what? Newton, we can give it up. Force of buoyancy can be applied in various appliances such as, first one is what? Submarine. The submarine, what else we are using? What else the Defense Academy, defense people were using it to detect the enemy ships, or else if any enemy ship is targeting us under the depth of the water, we can identify that particular thing, that is nothing but what? Submarine. This submarine it works upon principle of what? Force of buoyancy only. It consisting of one tank, the tank is called as Balsat tank, we can call it a ballast tank, we can call it a. If the tank is completely, as it is entering into deep of the water from the particular from the sea, it will enter into the particular ballast tank. As the water is increasing gradually in the ballast tank, what happens there itself? The buoyancy force acting upon that particular submarine will be gradually decreases. Due to decreasing of that one, the submarine will be immersing totally into the depth of the sea. Simultaneously, if you want to put a submarine to float on surface of the water, the water which is entering into this particular ballast tank will be get stopped, and slowly the water will be ejecting outside from that particular ballast tank. Due to that reason, the upward force, the buoyancy force acting upon the submarine will be gradually increases. Due to increasing of the particular force, the submarine slowly rises up on the surface of the water and it floats on surface of the water. That is regarding our application of submarine. Next application is what? Hot air balloon. Hot air balloon is what? The balloon consisting of what? Air. As we are increasing pressure by applying certain temperature, by lighting it a fire to a gas and allowing that particular gas to be entering that particular balloon, what happens there is an upward force acting upon that particular balloon will be gradually increases. Means what? Force of buoyancy will be gradually increases. Due to increasing of force of buoyancy within that particular balloon, what happens there? That balloon starts slowly rises up and it will be moving in the air. At one particular point, what happens there? We'll observe that itself. If the force of buoyancy is equal to that of gravity force there itself, If it is equal, the balloon remains steady. The balloon remains steady. That is the concept of balloon. Now it can be used force of a buoyancy within there also. Then ships also ships. The construction of ships. Ship is made with a certain shape consisting of what? Hollow space. So that what happens, air pressure can be get acted upon the surface as it is acting air pressure on the hollow surface of the particular shape. The water which is existing on surface, the density of ship will be lesser than that of the density of water. Due to that reason, the ship will be floating on the surface of the water there. By allowing that as surface of the particular sheet is gradually increases, more force, upward force will be acting upon the surface of that particular, from the bottom of the water, the more upward thrust will be acting upon that particular ship sheet, so that the ship will be floating on the surface of the water. That is next thing, that is third one there. Fourth one is what? Fishes. The species which will be floating on in the water, the fishes live in water. It consisting of air sacs. As it is taking air into the particular, through the particular air sac, as it is taking air into the particular air inside, it will enter into the bladder. So that what happens there, as the air is gradually increases, so that what happens, upward thrust will be acting upon that particular fish. Due to that reason, fish from the bottom of the sea, slightly it can be get raises up due to increasing of one force. That force is called as force of buoyancy. These four applications can be given for what? Force of buoyancy concept. Now this particular force of buoyancy, how we can measure? Measuring of the force of buoyancy. To measure buoyancy there, material required are nothing but what? Spring balance, stone, water, as well as a jar. These all things are required there. Spring balance is required, stone, water, as well as jar will be required there itself. First of all, take a spring balance. For the of known weight nearly equal to 1 kg weight, spring balance you take it up, which can sustain up to 1 kg only, which can accurately measure up to 1 kg only. And place, add a stone, the stone what is taken there, fix that particular stone to this particular spring balance. And as we are adding a particular stone, fixing to a hook, as we are fixing up with it, as we are tying that particular stone to the particular hook, what happens there, we'll observe the reading within this particular spring balance. Note down that reading. Let it be as what? W1 grams. After noting the weight of the particular stone, before immersing into the water, note down its weight is equal to how many grams? W1 grams. Later on, take a beaker consisting of half-filled with the itself. Within that half-filled beaker, allow this particular stone to be immersed in that particular water. As soon as they allow this particular stone to be immersed in this particular water, what happens there itself? We'll observe a weight. The weight will be gradually decreases there itself. Note down that weight also. Note down that weight also. Let that weight be as W2 grams. Let that weight be as W2 grams. You compare. Compare the differences between these two weights. That means what? W1 minus W2, if we take it up, we'll get how much weight does this particular when it is before immersing in water, what is the weight we know it up? After immersing in water, what we know that what is the weight there itself. If we subtract these two things, we'll get one weight. That weight you consider it as what? W3 grams. This weight will give us nothing but what? How much weight, how much force is acted upon the stone when it is immersed in water. That is nothing but what that force is called as force of buoyancy. That force is called as force of buoyancy. The body, the immersed stone which is losing apparent loss of weight because of one force, that force is called as what? Buoyancy force. That weight can be given as what? W3 grams. W1 minus W2 will give us W3 grams. That force exerts upward force on the stone and reduces force of gravity, which will be acting upon the stone. As it is acting upon the stone and is immersing in the liquid, simultaneously gravitational force will be also acting from the center of the stone in downward direction. So both will be acting in opposite direction. As they are operating in that direction, what happens? Which reduces force, which reduces weight of a particular object. Due to that reason, weight is the apparent laws of weight is taking place due to acting upon force. That force is called as buoyancy force. In that particular way, we can measure the force of buoyancy. We can measure force of buoyancy. Thus, the apparent loss of weight of the body is equal to that of the force of buoyancy. We can give it up. The apparent loss of weight of an object is nothing but what? Equal to the force of buoyancy. In this particular way, we can measure the weight of the force of buoyancy by using spring balance. By this we have completed our topic, children. Try to analyze this topic clearly. What is buoyancy? We have seen it up. And what is the main cause of the particular buoyancy? Applications we have seen it up. Simultaneously activity and how we can measure the buoyancy of force. We have seen, try to analyze the concept. Thank you, children.